Hi guys, in this video I'm going to be showing you the proof of how 4 is equal to 5. Before we start this proof, we need to remember what the expansion of this set of brackets is. A minus b whole squared. Well, we know that this just expands to a squared minus 2ab plus b squared. Okay, and we will be referring back to that expansion later on in the proof. So the first step will be to start with a true statement. Minus 20 is equal to minus 20. And you'll see why we've chosen minus 20 in just a second. In line number 2, we can rewrite this minus 20 on the left-hand side as 16 minus 36. And on the right-hand side, we can rewrite it as 25 minus 45. Now, the reason why I've chosen 16 and 25 is because they are 4 squared and 5 squared respectively. So in line number 3, we can just rewrite this as 4 squared minus 36. That's equal to 5 squared minus 45. And you'll see here that both sides of the equation are still equal to each other, because 4 squared minus 36 is still minus 20, and 5 squared minus 45 is also minus 20. So in line number 4, what we're trying to do is we're trying to get both sides of the equation in the form a squared minus 2ab plus b squared. Okay, we have our a squared term. On the left side, the a squared term is 4 squared. On the right side, the a squared term is 5 squared. But we're trying to get this minus 2ab term to be made from this minus 36 and from this minus 45. So this minus 36, right, we need to rewrite it so it's going to be like minus 2ab. Since we know what a is already, we can just rewrite this minus 36 as 4 times 9, right? Because 4 times 9 is 36, and a is 4. Similarly, on the right-hand side, 5 squared minus, our a is 5, so we can just write 5 times 9. 5 times 9 is 45, 4 times 9 is 36. And now we have our a, and we also have our 2b. So our a is 5, and our 2b is contained within this 9. Similarly, our a is 4, and our 2b is contained within this 9. We need to separate that 9 into a 2 and a b, right? So we can just divide the 9 by 2. We have 4 squared minus 4 times 2 times 9 over 2 is equal to 5 squared minus 5 times 2 times 9 over 2. And what you'll see here is all I've done is I've just taken out that 2 from the 9, and then I've multiplied it by 9 over 2, because 2 times 9 over 2 is still 9. Okay, and I'm just going to rewrite both sides of the equation now in a much more precise form, a squared minus 2ab, just so you can kind of clearly see where this is going. So a squared is 4 squared minus 2 times 4 times 9 over 2 is equal to 5 squared minus 2 times 5 times 9 over 2. And now you'll see it's exactly in the form a squared minus 2ab. We've got a squared minus 2ab, b is 9 over 2, a is 4. And here we've got a squared minus 2ab, a is 5, and b is 9 over 2. So the last thing we need to do to get it into this form exactly is to add that b squared term onto both sides. And we already know what b is 9 over 2. So we can just add 9 over 2 whole squared onto both sides. So to do that, we'll do 4 squared minus 2 times 4 times 9 over 2 plus 9 over 2 whole squared is equal to 5 squared minus 2 times 5 times 9 over 2 plus 9 over 2 whole squared. And remember, when you add something to both sides of an equation, the equation still remains equal. Now what we're going to do is we're going to factorize both sides of the equation into their respective forms, a minus b whole squared. So line number 8, what we'll do is 4 minus 9 over 2 whole squared is equal to 5 minus 9 over 2 whole squared. And you can see I can do this because a is 4 and b is 9 over 2, which means a minus b whole squared is 4 minus 9 over 2 whole squared. And on this side, a is 5 and b is 9 over 2. So a minus b whole squared is 5 minus 9 over 2 whole squared. Okay? Now we can just square root both sides. You can say 4 minus 9 over 2 is equal to 5 minus 9 over 2. And finally, we just add 9 over 2 to both sides, and we get 4 is equal to 5. So that is how you prove that 4 is equal to 5 using just some simple basic maths and some factorization. So what went wrong here? Where did the proof fail? Let me know in the comments if you can find in exactly which line this proof failed, and I hope you've enjoyed watching this proof, and do let me know where exactly the error lies. Thanks for watching.